Assalamualaikum everyone. My name is Nurish Najwa Natasha binti Mat Fadil and my metric number is 2024248164. Now, I will explain the meaning of differentiation and what are the technique of differentiation. Differentiation is a topic in calculus that studies the rate of change of one variable with respect to another. In simple words, it tells us how fast something is changing. For example, if distance changes with times, differentiation helps us find velocity. It also helps us find the gradient or slope of a curve at a certain point. The result of differentiation is called a derivative, usually written as dy over dx. This derivative shows how y changes when x changes. There are several techniques of differentiation. The most basic one is the power rule, which is used for function with powers of x. Next, we have the sum of different rule, where each term is differentiated separately. For more complex function, we use the product rule when two functions are multiplied, and the quotient rule when one function is divided by another. Lastly, the chain rule is used for composite function, which means a function inside another function. Overall, differentiation is very useful in solving real-life problems involving motion, growth, and change. Thank you.
Hi, good day everyone. My name is Nurin Aida Bagis binti Nisha. My matrix number is 20242555726. So today I will explain how to find dy over dx for the given function using the product rule and the quotient rule. So let's start with the first question. The given function is y equals to 4x squared square root 5 minus 6x. So this function is a product of two terms. So we apply product rule. First, let u equals to 4x squared and then v equals to square root 5 minus 6x. So first, we differentiate u and v. First, differentiate u. And it will be du over dx equals to 8x. And then differentiate v. Since v is a square root function, we use chain rule. And then it will be dv over dx equals to negative 3 over square root 5 minus 6x. So, the product rule formula is dy over dx equals to u v prime plus v u prime. And then we substitute the value into the product rule. And then this is the answer. This is the derivative of the function using the product rule. And then let's move to the second question. The given function is y equal to sin 5x squared over 2x plus 1. This function is a fraction, so we use quotient rule. Let u be sin 5x squared and then v be the 2x plus 1. We differentiate u using the chain rule and then it will be du over dx minus 10x cos 5x squared. And then we differentiate v and it will be 2. The quotient rule formula is dy over dx equals to vu prime minus uv prime over v squared. And then we substitute all the value into the quotient rule. And then this is the answer. This is the required derivative for question B. In conclusion, first question use the product rule and the second question use the quotient rule. And both of the question involve the chain rule. That's all from me. Thank you.
I will explain how to solve a calculus problem using implicit differentiation. Question 3. Firstly, we need to differentiate both sides with the respect of x. For example, from 2y will be to dy over dx. For learn to x will be use the list of formula and same goes to the right side. And then for the learn to x, it will be 1 over 2x multiplied to 2 and it will be 1 over x. Now bring all dy over dx term to one side, which is this side. To simplify, subtract all dy over dx value and put other side in the bracket. Lastly, make dy over dx as the subject.
I will explain the questions more. First, we require to use linear approximation to estimate the value. First, we define the function as this allows us to apply differentiation and linear approximation easily. Next, we differentiate the function with respect to x. The derivative of x squared is 2x, and the derivative of therefore, the derivative of the function is, since 4.01 is very close to 4, we choose the initial value x initial is 4. This choice simplifies the calculation because the square root of 4 is easy to average. Then we calculate the small change in x. Use the linear approximation formula. We substitute all the non-value. Hence, using linear approximation, the estimated value of is 15.581, correct to 3 decimal places.